Global illumination. In this tutorial, you will learn about advanced lighting techniques in setting up global illumination for your Unigine scene. If we create a simple outdoor scene with some interiors and illuminate it with a single default world light source, we can see how flat the scene looks. We introduce the static voxel lighting feature provided by a new light source type, Voxel Probe. To add it to the world, choose Create, Light, Voxel Probe. Go to the Voxel Probe tab of the Parameters window and click Edit Size. Now you can cover the whole building in the scene by dragging size manipulators of the probe. Voxel Probe represents a box volume which projects a 3D voxel lighting map onto all the geometry within. Each pixel of the light map corresponds to one of the 6 sides of the corresponding voxel, thus making it possible to simulate accurate indirect lighting. By default, the probe has no voxel map and illuminates with black color. You can generate a new light map via the Bake Lighting tool. Bake Lighting tool enables you to pre-compute and save data describing how the light rays bounce multiple times around the static geometry, producing indirect lighting at every voxel. Number of bounces parameter describes how many bounces are to be calculated. By default, this parameter is set to 1, but you can increase it up to 32 without a significant performance hit. To bake lighting with default settings, simply click Bake. The lighting is calculated for each voxel of the probe. You can define the number of voxels calculated and rendered per frame via the voxels per frame parameter. Higher values increase calculation speed, but slow down the UI response. As the process is completed, new details will appear on surfaces, ambient occlusion, and indirect lighting. Let's add a sample object to the scene. The huge impact of the voxel probe on it is hard to miss. There is also diffuse reflection of the red floor and environment. When we put our vehicle to an indoor area, we can see that it is illuminated properly according to its position, taking into account all static environment occlusions. When we increase the number of bounces up to 4, we also increase the number of iterations for scene lighting calculation, as one iteration is performed for each bounce. After rebaking, the room has become brighter, as now more incoming photon bounces are taken into account. You can turn any object into a light source and bake it to global illumination by simply enabling emission and emission-baked GI states for its material. Just look at this softbox. It emits pretty enough light to illuminate the building. As we use a multicolored texture, we get baked rainbow-like lighting. Along with dynamic light sources and emissive surfaces, you can also use custom HDR images to illuminate your scene. Having set an HDR cube map as the environment texture and all other light sources disabled, we can bake global illumination. As a result, our buildings are illuminated the same as if we'd used ordinary light sources, but at a lower cost. Let's go back to our indoor area and decrease roughness of our floor and walls materials. By default, the environment cube map is rendered on reflective materials. We can notice the default reflected sky and horizon on the walls. Real-time reflection are expensive to compute at runtime, especially in complex scenes. That's why we suggest using pre-baked reflections provided by the Light Environment Probe. We add a new probe and adjust its size with our room by dragging the manipulators. After rebaking lights, the environment probe contains a new reflection cube map, so now we see the right reflections projected on the surfaces. The best way to improve static reflections is to enable the SSR effect via Rendering Features SSR. In this case, the pre-baked reflections of the environment probe are augmented with real-time screen space reflections, taking the look of our scene to a new level. Let's take a look at Voxel Probe's parameters. The most important is the voxel map resolution, which is calculated from the sizes of a single voxel and the whole probe. Higher resolution provides better quality, but increases memory usage, so adjust it well. You can use the voxel size multiplier parameter of the Bake Lighting tool to affect the size of all voxel probes in the scene. It can be used when a temporary change of baked lighting quality is needed. Attenuation distance and power are usual parameters for a light source and define the distance and speed of lighting falloff. Render Parameters group contains main render settings for the light source, such as intensity, color, masks, and so on. We can use the Use Sun Color option to make the voxel probe affected by the sun color. Changing the time of day with this option disabled won't affect the probe, and the lighting shall remain the same as it is static. But as we enable this option, we can see that room lighting changes during the day-night cycle. Make sure you enable this option for all relevant probes to maintain lighting consistency. So we should do the same for the probe on the table. Now it behaves as it should. Voxel probe affects ambient lighting as well as reflections, so we can adjust color and intensity for them in the corresponding groups. Bias parameter in both of these groups can be used for fine-tuning. Cubic filtering toggles the texture filtering between linear and cubic, which is more accurate, but expensive and not necessary all the time. Minimum and maximum visibility roughness parameters define the range within which the reflections of the voxel probe are visible. Use it to control overlapping of the specular reflection of the environment with reflections of the voxel probe. Baking settings are relevant to light baking process only, so when you change any of them, you should rebake lighting. This group of parameters controls quality of resulting global illumination. It includes sampling parameters, number of light rays, and clipping distances. Default values are optimal for most cases, so you can leave them unchanged. Next, 3 parameters are used to fix the undesired light bleeding effect caused by the concept of the voxel probe. If a row of voxels protrudes beyond the walls of the building, it receives light from outside and affects neighboring voxels, making them brighter than they should be. So adjust these parameters for best results if such artifacts appear. By default, only the voxels intersecting with geometry are baked, while empty ones are skipped. You can bake all empty voxels too by enabling the Bake Internal Volume option. This ensures realistic lighting for dynamic objects moving inside the voxel probe, as the lighting will be baked for the whole volume. But be aware that baking internal volume significantly increases overall calculation time. By default, to speed up the process, each subsequent light bounce is computed with higher quality than the previous one, with the last bounce always in full resolution. You can choose to compute all bounces in full resolution by enabling the Full Resolution Bounces option. But take note that 20 bounces in default mode are calculated faster than 2 bounces in full resolution. You can also choose which texture is to be used by the voxel probe. You can drop a pre-baked texture to this field to be used, or generate a new one just by leaving the field blank and performing the light baking. Now let us consider the environment probe. Let's add a reflecting sphere to see all the options. Apart from lighting, Environment Probe also defines reflections inside its volume, so a moving reflective object will get proper reflections corresponding to its location. Environment Probe Light Source has almost the same parameters as the voxel probe, but there are some specific ones. Box projection. This parameter is enabled by default. This means that the reflection cube map taken from the center of the probe is projected onto a box shape. This is the best way to reflect square-shaped interiors, but for all other cases, disabling this state and rendering reflections as a usual cube map provides a better result. All baking settings are specific for the Environment Probe. Environment Probe can be rendered in dynamic or static mode. This is controlled by the Dynamic option. In static mode, probe's reflections and lighting are baked into a cube map and remain the same. You can set various cube map parameters and grab it at any moment, just the same way as with the Bake Lighting tool. You can choose to update the cube map texture with the Bake Lighting tool or not via the corresponding option. In dynamic mode, the probe grabs a cube map from the center each frame, which may cause a significant performance hit. There are parameters to set up for dynamic mode, such as resolution, clipping planes, and so on. For more details on global illumination, please refer to our online documentation.